My name is Daniel, and I represent Broad. But specifically, my role in Broad Group is I'm the managing director of the Broad Core digital building company. I'm an architect by training, but architects are kind of a small group because they speak a language sometimes is very difficult to communicate with. If you have some architecture friends, I'm sure you feel the same. So today I won't be speaking anything too specific regarding technology, but I would like to tell you the story of Broad in a more engaging way, I would hope. This presentation is going to call upon everyone to go meta. What does meta mean? In Chinese, we can understand it as 维度, 升维. I could be talking about going upon a higher level of thinking. So there's a German architect, goes by the name of Mies van der Rohe, who said less is more. And today I share with you my perspective of Broad's manifesto with all our disruptive technologies in going meta, and more is meta. To begin, I'd like to think on the scale of civilization. Everything we do today, all the carbon that we emit today stays in the atmosphere for not only decades, but centuries. That is on the scale of close to civilization. And every civilization, does it have to follow the pathway of rise and collapse? I would hope our current civilization do not. And that's why low carbon is so important. Let me tell you the story. The story of course, begins with the founder of the company, Broad Group, who's also conveniently my father. About 10 years ago, the disaster of Wenchuan earthquake left a scar in many Chinese people's memory and the world's memory. The building that collapsed killed hundreds of thousands of people. So the chairman decided to create a cheap enough steel modular construction that can withstand magnitude 9 earthquake. Then he founded the company Broad Sustainable Building. Over the past 10 years, we have to build 60 such type of buildings. We have the hotel, some of you are staying in the New York Hotel. Well, it was built in 5 days, and it was built in 2009, sorry. And there's the T30. It was very, very popular on YouTube. It got on Wire magazine. 30 stories, took us about a week. And J57, which stands behind us outside the pyramid, took 19 days. So with all these modular technology, we found that we were in a dead end because steel has lifespan, because they corrode. Today, I'm going to be talking about going meta, going everlasting. Can we create buildings that outlive the average age of our past civilizations? And I think that's possible. So, about 3 years ago, the chairman made a big decision to stop all those buildings which you see today that are being built in Broadtown. And a memory came back when he went to the United States to buy a private jet. A very non-environmental friendly behavior, which he has stopped. So the plane that he bought from the United States right now hangs on the left corner, my left corner of the pyramid. He grounded the plane. But when he was in the factory of Learjet, he saw a material made from stainless steel that's like a honeycomb. And he said, "Can I buy my jet, but it has to be made from this material?" The salesman said, "No, you can't afford it. This is for NASA." So he decided 3 years ago to investigate how could we make this material cheaper, more affordable, more widely available, and perhaps this could solve the lifespan issue of our construction today. to make them safer, more long-lasting, therefore cheaper for future generations. So, after hundreds of times of failure, he succeeded. And to make this material cheap enough, he has to employ robots, employ basic. So digital transformation is at the heart of this disruptive technology. So the first building right now stands about 200 meters away from us, and it was built in 24 hours. The whole building is very lightweight. It weighs only 30 tons, and it's made entirely with stainless steel. It's the first ever building to be built without any concrete. Concrete and rebar have a lifespan, but stainless steel buildings don't have to. So does our civilization don't need to have a lifespan. And this material is stuffed with rock wool insulation, so it behaves soundly, high performance in hot environments and cold environments. Currently, we're building this very daring structure. As an architect, we say this is almost like the Japanese metabolist movement, where modularity sings from the appearance. Right now it's being built about 400 meters away from us, and it's already topped. And imagine how it would compare to civilization. Architecture taking inspiration from the past. The Hanging Babylon, the Hunan Diaojiaolou. Very importantly, we need to take our lesson from the past. We cannot make buildings that will become waste and garbage. So, can we make this technology easy enough, like Lego, that we can ship them in containers, diffuse this technology in high efficiency around the world, because construction industry emits about 50% of the world's CO2. And at the same time, can we use many digital technologies, such as VR, AR, to bring this heavy material, new material, to the world without having to go through shipping. And also, this building it's being built on my pocket supercomputer, has already a WeChat app. When it's online, it will tell you how much CO2 it's emitting and has a full life cycle record from production to operation, and hopefully hundreds, thousands of years later, repurposing, because stainless steel is recyclable with circular economy. And you can use this wherever you are, inside the building, outside the building, and into the future, there will be a cloud that controls all our smart buildings, smart cities. When technology, digital technology takes a physical form, it's like a robot. So imagine these are the biggest giant robots we will build, and they will protect our future. So how can we bring this to more people? Today, we have sharing with you some of our Sky City Challenge submissions, which is in the T area in the back of the room. These are architects from all around the world. The first year was 2017, and this year was 2019. And we have received hundreds of submissions and come to with our world-famous leading architects from MIT, from space agencies, and we have narrowed down top 30. And these are some of the proposals that have taken our challenge to use the broad core sandwich stainless material to create the future of housing. And their design standards, we only tell them you have to fit one housing unit into a container, and it has to be a complete one house. And then you can modularize it and build communities. You can build them with inspiration of Chinese Tulou to help with social projects. So they all have understood our material. It is so hard to bring physical technology to the world because atoms are heavier than bits. Digital technology in the past decades have transformed our lives, but the next step is physical technology, because they're our bridge towards a low-carbon future. So many of the designs they have that comes from these young designers, young architects, they're like IKEA. They're trying to make low-carbon, long-lasting buildings like products, like the next killer app. Many of them already have proposed applications, and many of them tell stories wonderfully with visual communication. Maybe sometimes I imagine these buildings don't have to stay on Earth, they can go to Mars. So, as it comes to an end of my speech, I'd like to invite everybody to go meta, to say yes to innovation, and to bring together a low-carbon future to the world. And as Broad, we hope our root technology that comes from this material can become a physical platform for many of the hydrogen technology, digital technology, even future meat technology, and renewable energy technology. Thank you very much.